Page 3, honors chem exam. It's going to require some naming rules that you hopefully wrote on your periodic table. They'd look something like this idea about acids have special ways of naming, about changing the endings. So when I'm at this part that says, name the following acids or bases, if it starts with an H, I know its last name is acid. If it starts with an H, I know its last name is acid. Base doesn't have that last name of base. So this one that's OH and doesn't start with an H, that's a base. And that's just easy. Here's another one that starts with an H, it's an acid. I'll start with this one right here. It's iron hydroxide. What I have to do is just double check to make sure that I realize that it must have been the iron with a +3 charge, iron 3 hydroxide. All the other ones are acid. The acid name comes from its anion, negative ion, SO3. When I look on the back here, SO3 here is sulfite. Sulfite becomes sulfus, except in this case we put the UR back on there. It's sulfurous acid. If you put sulfus acid, I'd be okay with it. Sulfurous acid is more correct. PO4. According to the back of here, PO4 is phosphate. Phosphate. Checking the rules, 8's phosphate becomes phosphic. And again, we're going to throw on back on the OR, phosphoric acid. And HF. F is the fluorine, so it's the fluoride ion from the nonmetal ide side. Ides, fluorides become hydrofluoric. Got to remember that hydro in there. The monoprotic usually are hydro. So hydrofluoric acid. Same idea on the other way down, the nickel 2 hydroxide, it's nickel with a +2, hydroxide with a -1. When we crisscross this, it's nickel hydroxide taken twice because I need 2 of those. Hydrobromic acid starts with H. Hydrobromic, let's see, let's go back here. If this said hydrobromic, it came from the bromide ion. That's on the nonmetal ide side, which is Br with a -1 charge. It's just that simple, a monoprotic H with a Br minus HBr, hydrobromic acid. Carbonic acid also starts with an H, but we have to use this to figure out what its ending will be. Carbonic comes from the carbonate ion. I got to go find that. The carbonate ion. Carbonate. There it is. It's CO3 with a -2. So if it's CO3 with a -2, it's going to be a diprotic acid. Finally, chlorous acid. Chlorous comes from the chlorite ion. That's not on the front, not on the nonmetal ide side. It's on this side where the 8's and ites. Find chlorite. There it is, ClO2 with a -1 charge. So that's ClO2 with a -1 charge. That is a match made in heaven. It's H, ClO2, chlorous acid. The next ones are making a stock solution, including a sketch. How do you make something with a stock solution? You don't go with it to the scale. A stock solution is liquid. You're going to need some water. We're going to have to figure out how many milliliters. You're going to need your stock solution, and we're going to have to figure out how many milliliters of that to add it up. When I'm all done, I need a grand total of 250 milliliters. 250 milliliters is my total, and I'm going to have to figure out how much water based on that number. That's not how much water to add. I need a 0.8, or I have a 0.8 molar stock solution. And so the dilution and the molar and the titration formulas look exactly the same. We're just after different stuff. M1V1 equals M2V2. What do I know? I know the molarity of the original stock solution. What I don't know is how much I'm going to use. I also know, all right, I did this backwards. My stock is actually 16 molar. Got to read. I'm making 250 milliliters of a 0.8 molar. The stock is 16 molar. I don't know how much to use. My new solution will be 0.8 molar. And I do know that I want 250 milliliters of it. Now I'm going to solve for V1. I got to figure out what volume of the strong stuff. Divide by 16 molar. Divide by 16 molar. Calculator. 0.8 times 250 divided by 16 equals 12.5. It's some strong stuff. 12.5 milliliters is all I need to make that weak acid. Some people ask me, do I have to change that to liters? I don't, because I want to know how many milliliters, so I can, if I start with milliliters, I can end with milliliters. So 250 milliliters is what we want total, but I already have 12.5 milliliters of liquid. 250 minus 12.5 is 237.5 milliliters. It needs both the math and the drawing. Next one is making it out of solid calcium hydroxide. That's going to need a scale. That's going to need some mass. I'm going to use that idea that molarity is simply moles of solute. That's what I'm doing. That's what I'm dissolving, and in this case, calcium hydroxide, divided by liters of solution. So when I start plugging in, what do I need? Well, I'm trying to make 250 milliliters, which now in this case I do need to change this to liters because the molarity formula is in liters. I'm not just trying to figure out how many milliliters of something. So molarity is going to be 0.8 molar. That is equal to the moles of solute. I don't know. That's what I'm trying to figure out. And I'm going to need 0.25 liters times 0.25 times 0.25. 0.8 times 0.25 equals 0.2. I'm going to need 0.2 moles of calcium hydroxide. How much is that going to weigh? Well, 1 mole of calcium hydroxide, I didn't figure this out at first, looks like 40 plus 32 plus 2, about 74 grams. 32. 0.2 times 74 is 14.8. I will need 14.8 grams of calcium hydroxide. It's like powder stuff or crystally stuff. And I'm going to need to add some water. How much water do I add? In this case, I'm going to add 250 milliliters. I did not check that one before. If that one is wrong, someone let me know. I'm trying to do that in my head, some of it. Next one, nitric acid reacts with calcium hydroxide, and my mission is to write a neutralization reaction. I have to figure out the formula for nitric acid. Nitric comes from the nitrate ion, which is NO3 with a -1. It's an acid, so it starts with H+. That's a match made in heaven. H, NO3, reacts with calcium hydroxide. Calcium is a +2. Hydroxide is a -1. Crisscross. Calcium, OH, taken twice. So what happens? Well, it's really just a double replacement reaction. The calcium gets to dance with the nitrate. You got to be careful. Calcium's +2. Nitrate's only a -1. It's going to take, one of those and 2 of those. Calcium, nitrate with a 2 right there. And it also is going to, now the H's dance with the OH's. In other words, it simply makes water. It's okay to write it as water, but if I write it as HOH, it might help me balance this a little bit better. So when I'm balancing this, when I'm counting this up, I'm going to use this space. I'm counting H's, NO3s, CAs, and OHs. And I'm going to write it in the same order over here, CAs and OHs. If I choose to think of that H2O on the right side as H and an OH, it helps me hopefully count this up. One of these and one of these and one of these and two of these. But on this side there's one H, one OH showing so far, one CA, and two of these. So I got to double my nitrates on the right side. I mean on the left side, I got double the nitrates on the right. So if I put a 2 here, that changes this to 2, but it also changes this to 2. I also have to double my hydroxides on the, I got 2 here and only 1 here. If I put a 2, that'll double my hydroxides, but that also made my hydrogens be different. If I go down the line, I see 2, 2, 1, 2, 2, 2, 1, 2. That is a balanced reaction. Finally, sulfuric acid. Johnny was a chemist's son, but Johnny is no more, because what Johnny thought was H2O was H2SO4. That is sulfuric acid. We could use the rules. I'm going to use the rhyme. Sodium hydroxide. That's a real common one. Sodium +1, hydroxide -1. That's it. Switch dance partners. Sodium gets to dance with the sulfate, but it's not a 1-to-1 ratio. Na is a +1. Sulfate is a -2. It's going to take 2 of those sulfates to get the job done. And it's also going to be dancing with, or now the water H's and the OH's get together. It's okay to write it as H's and OH's. It might help you balance it. This one I think will balance a little simpler. Well, actually, the last one was pretty simple too. If I have 2 sodiums on the right, I'm going to put 2 sodiums on the left. If I have 2 OHs on the right, I'm going to put a 2 OHs on the, and that's good because I had 2 H's over here, I have 2 H's over there. I think that one is balanced. And that is the end of that page.